So in the circuit, we're being asked to compute I naught using source transformation. So I naught is in this branch, so I'm just highlighting it so I make sure not to convert it or just lose it by mistake. Again, it's like in source transformation is not always useful, but in this particular circuit it might be. So let's get started with that. And I believe the only pattern we can do transformation on, well, there are two patterns we can do transformation. We have these two that are current source and a resistor in parallel, but we will not do the conversion on that particular one because we need the I naught. So I'm gonna just keep it at least for some time. And now the rest that we have is the following. I believe we can convert this 3 and the 2 milliamp because they're in parallel, and I don't think I can convert anything else. So at least at this stage. So let me just redraw that circuit. So of course a current source gets converted into a voltage source and in series with the 3 ohm. So we can, well, the 3 kilo ohm, the 3 kilo ohm stays this way, and the voltage source becomes plus minus, and then we have another voltage source that was already there, and that becomes basically minus plus, and that's 6 volts. So let's compute the value of that voltage source. Well, just as a reminder, Vs will be just simply Is times R, and of course Is will be Vs divided by R. So I'm interested in figuring out Vs is just simply 2 times 3, and that will also be 6 volts. Okay, this is 2 times 3, of course kilo ohms and milliamps, so the result is in volts. And we continue drawing the circuit, and I believe this will be 6 kilo ohms, and what we have in here is another 2 kilo ohms, or just 2 kilo ohms, and we have a current source moving downwards, and that's 1 milliamp, and we have that 4 kilo ohms in here. Okay, and this is the resistor we're interested in, 4 kilo ohms, and this is basically, let me just make sure I highlighted, this is the current I'm interested in, and the current source stays the same, going downwards in here, and that's 2 milliamps. Okay, I'll highlight this again just to make sure that I don't convert it, because again it's the same pattern, but I will not do the conversion. So we take a look at these in here. So what we have is the following. So these 2 6s in here, the one that we see, let me just do that. So these 2 6s can be combined into 12 because they're in series. Think about them as 2 batteries in series. So 6 and 6 is 12, and they can be converted to a current source with that 3 kilo ohms. So what we will have in the next result is the following. We have 6 and 6 is 12, but I'm going to do a couple of things. I'll add the 6 to an 6 and make them 12, and I convert that resulting 12 and the 3 kilo ohms into a current source. Okay, so the 3 kilo ohm stays the same, it's 3 kilo ohms. Okay, but now the current source is actually moving upwards in here, and that current source is simply I believe it will be 12 volts divided by 3 kilo ohms, and that basically is 4 milliamps. Okay, and that becomes in here, and it is in parallel with 6 kilo ohms, and then we have the 2 kilo ohms in here, and we have 1 milliamp going downwards, and we have the 4 kilo ohms in here, and the 4 kilo ohms, the other 4 kilo ohms in here, and we have the current source that will be 2 milliamps. Again, I'll just make sure to highlight that this is the current I'm interested in, and this here is the branch I shouldn't be converting. Alright, so we take a look now. What we have is the following. I believe we have these two can be combined, the 6 and 3 can be combined together in parallel, and of course we have this source. Well, we convert them into 6 and 3 in parallel, and we convert them to a voltage source. So let me just do that. So it becomes a voltage source going back up down here, and that will be 6 in parallel with the 3, and that becomes 6 times 3 divided by 6 plus 3, which is I believe it will be 2 kilo ohms. It's 6 times 3, which is 18, divided by 6 plus 3, which is 9, which is 2 kilo ohms. So this particular resistor will be 2 kilo ohms, and then I believe we have another 2 kilo ohms in here, and we have the current source going downwards, and that's 1 milliamp. Before I forget, let's compute the value of this voltage source in here, the one we converted. So the resistor that is 6 and 3 in parallel become 2, and I have this as a 4. Well, what would be the voltage source value? Well, the V equals, as you remember, it's Is times R. So what we have is 2 times 4, which is 8 volts. All right, so we do that, and then we have the 4 kilo ohms in here. Okay, the other 4 kilo ohms, and we have the 2 milliamps. Going downwards, we highlight this here is the current we're interested in. This is I naught, and I'm going to highlight it in pink so that we don't convert it. So if you think about it now, we have the 2 and the 2 are in series, and they're in series with an 8 volts in here. So we combine them into a 4 kilo ohms in series with 8, and we do the conversion as well. We convert it to a current source. So at this point, it will be current source moving upwards in parallel with a resistor that is 2 plus 2, 2 plus 2, which is just simply 4 kilo ohms. All right, and what about the value of that current source? The value of this current source will be 8 divided by 4, which is just simply 2 amps, or 2 milliamps, sorry, because we're dealing with kilo ohms. And then, of course, we have the current source that is going downwards is milliamp, it's still the same. This resistor here is 4 kilo ohms, still the same. This one here is still 4 kilo ohms, still the same. And this one here is the 2 milliamps going downwards. Of course, this one here is connected, this one here is connected. Let me make sure I highlight this here as the current I'm interested in. This is I naught, and this one here is the highlight so that I don't convert it. All right, so what do we have now? Well, let's do this here. These two are in parallel, and they're in parallel with the 4 kilo ohms. So I can technically combine the 1 going downwards and 2 going upwards into one source. That will be a current source going upwards by 1 milliamp, and then I convert it. So I'll have these two here. Let me just highlight it. So these two here will be converted to 1 milliamp, okay, going upwards because 2 is higher than 1. And then it will be in parallel with that 4 kilo ohms. So I'll convert it to a voltage source. So it will be a voltage source that looks like that, which is plus, minus, and then I have the 4 kilo ohms in here, okay, and I have the other 4 kilo ohms. So what's the value of this voltage source? Well, the value of this voltage source is simply 1 times 4, which is 4 volts, okay, because it's 1 milliamp times 4 kilo ohms, and that's 4 volts, okay. So we do this, and I believe we highlighted that 4 kilo ohms. This is the other 4 kilo ohms that we're interested in, and this basically is downwards 2 milliamps, okay. So I'll highlight this one here, and I make sure that this is the I naught I'm interested in. And so what's next? Well, what's next is the following. These 4 and 4 will get combined, and then they're in series with this voltage source. So we're going to do a conversion to a current source. So at this point, it will be a current source going upwards, and in parallel with 4 plus 4, which is 8 kilo ohms. And that's also in parallel with the 4 kilo ohms in here. This is the one we're interested in. And then there's a current source in here that's going downwards by 2 milliamp. So let's figure out the value. The value in here will be, I believe it's a current source, so it'll be 4 volts divided by 8, which is just simply 0.5 milliamp going upwards. Again, the current we're interested in is this is the I naught. And of course, I'm going to highlight it in here just so that we can see it. So what's next? Well, I think what's next is let's combine these two sources together, and we'll keep that 8 kilo ohms. I'm not going to do any conversion. So combining these two sources together, I'll end up with, I believe it will be 1.5 milliamp going downwards in parallel with an 8 kilo ohms, in parallel with a 4 kilo ohms, the one that we started with. And the current I'm interested in is I naught going downwards. So the way we can compute it is, again, we can continue with the source transformation, or we can recognize that this is just simple current division. So if I'm interested in I naught, it's just simply, well, the current that gets divided goes upwards and upwards, and the current I'm interested in is going downwards. So that means I have to put a negative in here, and that's negative 1.5 milliamp times, well, the resistor I'm interested in is the 4, so I'm going to put 8 in here, and 8 plus 4. And that number would be negative 1 milliamp.